Assalamualaikum. Today we will be discussing about experiment 4 of the subject code PHY110 titled linear motion. The objective of this experiment is that we will be able to investigate the relationship between force, mass and acceleration. The other objective is to determine the acceleration of an object under a varying forces. This experiment is an application of Newton's second law and helps us to visualize how force, mass, and acceleration are related. It also gives an opportunity to explore how forces act on objects and how the resulting acceleration is dependent on the system's mass. Newton's first law of motion stated that objects that do not experience any net force will continue to move in a straight line with a constant velocity until they are subjected to a net force.
Newton's second law of motion. Newton's second law states that the force acting on an object is equal to its mass multiplied by its acceleration. This means that for given mass, increasing the force applied to an object will cause it to accelerate faster. Conversely, for the same applied force, an object with more mass will experience less acceleration. Force. The blower applies a controlled force on the glider, while the slotted masses provide an additional force through gravity via the pulley. You can adjust total force by changing the mass or the blower intensity. Mass. The mass of the glider and the slotted masses on the hanger can be adjusted, which changes the total mass of the system. A heavier system will accelerate less for the same amount of force. Acceleration. You can calculate the glider acceleration using the photogate data, which track changes in velocity over time. By measuring the acceleration for different forces by adjusting the blower or the mass, you can verify Newton's second law of motion, which relates force, mass, and acceleration.
In this experiment, if there were no force acting on, and for example, if gravity wasn't pulling down, both mass would stay at rest, and there will be no motion in the system. However, when we release, gravity acts as an external force on, causing it to accelerate downward. This pull-on is transmitted through the string, which then pulls along the table. So, Newton's first law helps us understand that without the gravitational pull-on, there will be no movement in the setup, and both mass will remain at rest. Firstly, we have acceleration, the change in the speed or direction of an object's movement. Acceleration equals change in velocity or time. Secondly, we have force, interaction between two objects that cause a change in the motion of the objects. What impact can force have on objects? Make it move, make it speed up, make it slow down, stop it, cause it to change direction, cause it to change shape.
For the procedure, firstly, the linear air track is assembled as shown in figure 4.3. The pump is switched on and air is allowed to blow through the track for several minutes. The track is balanced by adjusting the screw on the leg of the track so that the glider remains stationary and does not glide to either end when released. One hook is inserted at one end and a flag is placed on top of the glider. Next, the mass of the hanger and the mass of the glider are measured and recorded. One end of the string is attached to the hanger and the other end is attached to the glider. Masses of 200 grams on the hanger and 80 grams on the glider are placed. The string is then placed over the pulley. The glider is positioned exactly before the photogate. The glider is released and the time shown on the photogate is recorded. The procedure is repeated 2 more times to obtain the time average value. The slotted mass on the hanger is decreased by transferring a mass of 20 grams to the glider. Step 8 and Step 9 are repeated. Lastly, the procedure is repeated 3 more times with 20 gram transfer from the slot mass on the hanger to the glider.
So this is the result that we got based on the experiment. Moving forward, this is the graph that we have plotted for the analysis. What does the graph tells us? Weight force F is directly proportional to acceleration A when the force increases. Then the acceleration will also increase. This indicates that F equals to ma. Next, this is the gradient m of the graph. For the uncertainties of gradient m delta m, we got 0.80 plus minus 0.19 kg. Next, the gradient is equal to the mass of the object. Therefore, the mass can be determined from the gradient. The larger the gradient, the greater the mass of the object. This is because a larger force is needed to produce the same acceleration if the mass is increased. This explains the relationship between the gradient m from the graph and the total mass.
The percentage difference that we got is 87.5%.
This is the factor that have contributed to the errors in the experiment that we have discussed. So this is the explanation on how to overcome the factors mentioned in the previous slide. Relationship between force, mass, and acceleration. The experiment confirms Newton's second law of motion, F equals to ma. It shows that the force applied to an object is directly proportional to its acceleration, and the proportionality constant is the mass of the object. This means that for a constant mass, increasing the force increases the acceleration, and for a constant force, increasing the mass decreases the acceleration. Acceleration under varying force. The acceleration of an object changes when the applied force varies. This indicates that the magnitude of acceleration is dependent on the magnitude of the applied force, validating the theoretical relationship A equals to F over m.